So this is lesson 7.1a in college algebra, and the name of this section is called Sequences and Series. And it just depends on how far we are in the semester, on how many lessons we have to go. But this quite possibly could be the last one, so bear with me as we get through this, as we will be doing some things that most of you have not done before. If you ever take a course in probability and statistics in college, or even at the high school level that I teach once in a while, you'll get a lot of this stuff. So if you're not getting it now, you're going to be getting it later. All right, so the first thing we're going to be talking about here are sequences. And they give us kind of a beginning story problem. Suppose that we invest $1,000 at 6% interest. Okay, that means that every year you're going to get, and it's compounded annually, which means every year you're going to get you're going to have your $1,000 plus 6% of your $1,000. So at the end of the first year, you're going to get your $1,000 back, plus you're going to make $60 after the first year. Now, if you put that $1,060 back in the bank, and they give you 6% of that, at the end of the second year, you'll have $1,123.60. And then if you take that and put it in the bank, and at the end of the third year, that's at the end of the third, and at the end of the fourth year, so you're making some good money as time goes on here. So 4 years, and you've went from $1,000 to $1,262. So you made $262 after 4 years for doing absolutely nothing. All right, so what we've got here is we've got a function basically, and that function looks like this: 1,060 after 1 year, 1,123.60 after 2 years. So you get an x variable, and you get a y. All right, so you're getting a pairing of these two. So 1, 2, 3, 4, and this dollar amount based on which year we have there. So a function, or a sequence, which is this, a sequence, 1, 2, 3, 4, etc., is going to be a function. And the domain of that function is going to be 1, 2, 3, 4. Okay, so the domain, the x values are going to be 1, 2, 3, 4, 5, 6, 7 are going to be sequential. They're going to start with 1 and go from there. There's not going to be decimals or fractions, or we're not skipping numbers. It's just 1, 2, 3, 4 sequential. All right, if we're going through here and we decide we're going to stop after a certain number. So let's say we're going to stop after 4 years. This is called a finite sequence. If we were to continue on into infinity, never stop at all, it would be an infinite sequence. Okay? All right, so blue, bottom of page 576, says sequence is an infinite sequence is a function having for its domain set the set of positive integers 1, 2, 3, 4, 5, ... meaning 6, 7, 8, 9, 10 into infinity. A finite sequence is a function having for its domain a set of positive integers, just like we do here, but instead of going into infinity, we're going to stop at n. Okay, so some number, n, and it's always going to be a positive integer. So you're going to start at 1 and go to n, or end at some number. We don't know what it is, so we're just going to call it n. Okay? Okay, so bottom of page 576, we have kind of a way one of these formulas is written. And so pretty much this is the y value when we put in the n value. Okay? And whatever this is, that's what's going to go here. So let's say that we're going to look at the first number. Okay? That's going to be 2 to the n power. What is n? Well, n is this number right there, which in this case it's 1. So a 2 is going to be 2 to the n, which is 2. Oops. Which is going to be 4. A to the 3 that is equal to 8. So you could really just write A3 equals 8 for this if they were just interested in that particular answer. All right, and you go all the way down to, let's say, 8 to the 5th. And that equals 32. So the first term of the sequence is denoted as A1. The fifth term is A to the 5th, or subscript 5 if you want to say subscript over and over. And the nth term, or general term, is A to the nth power. Okay, that's just the unknown. It's kind of like saying your x. You don't know what it is yet. You don't know what that last number is. They haven't told you what it is, but usually they'll tell you if there is a last number, what that last number is. Okay, so let's look at example 1. And, you know, this is just kind of an intro section where we're just hitting kind of the highlights of sequences and series. And in the next lessons, they'll be getting a little bit deeper into those. But like I say, we're not going to be getting into that. We're running out of time, and that's okay. All right, so example 1 says, find the first 4 terms and the 23rd term of the sequence whose general term is given by a to the n equals -1 to the n squared. Okay, let me show you something here. This -1 to the n, all this does is changes this number to positive, negative, positive, negative, positive, negative. So let's say that you had one, for your answers, you had 1, -2, 4, -8, 16, -32. Okay, so see how they switch back and forth from positive to negative? That's what this part does. So whenever you see -1 to the nth power, it just means we're going to go from one sign to the other, back and forth, back and forth, back and forth. So that's the reason for that. So if they're asking you to come up with a formula and they give you the answer and you see it goes like this, you're automatically going to put a -1 to the nth power, okay, because that's all that's going to do. You don't have to know anything else except that. All right, so that's our formula, and they're wanting to find the first 4 terms. So A1, A2, A3, A4. Oh yeah, and they want you to find A to the 23rd. So what that means then is wherever you see an n here, you're going to put this value. So in this one, that's going to equal -1 to the first power 1 squared. Okay, so I put a 1 here and here, here and here. Okay, let's do this for the 2. -1 squared, 2 squared. Same thing here. Okay, so see what I'm doing? I'm just putting in the numbers there. So this is going to get a -1 to the 23rd power 4 squared. Okay, so notice what happens here. All that happens with these -1s is if the exponent is odd, the answer is going to be negative. If the exponent is even, it's going to be -1 times -1 is +1. -1 times -1 is +1 times -1 is -1. So an odd number in the exponent will make your answer negative. So we can just do this. Oops, I'm going backwards, aren't I? Let's try it again. Oops, golly, what's my problem here? Negative, positive, negative, positive, negative. Okay, so that's what all of this does. Once I'm done with that, I can kind of make that go away. Okay, now let's look at 1 squared, 2 squared. Oops, this is 23rd, isn't it? Sorry about that. So that's going to be -529. All right, so see what I've got here? So my first four terms are going to be -1, 4, -9, and 16. And my 23rd term, because my 23 is odd, going to give me -529. All right, so again, this part right here gives me what is called an alternating sequence. Okay, so that's what we did. So whenever you see this again, that means we're going to get an alternating sequence. Our numbers are going to go back and forth from positive to negative. And one of the things I want you to notice, if you were to graph this, your x value would be 1, 2, 3, 4, and 23, and your y value would be what you get out of the function machine. So if you were going to graph this, we'd get 1, -1, 2, 4, 3, -9, 4, 16, and 23, -529. Now, this is not going to give you a line. You're going to graph this, and yeah, your points may look like that, but it's just the individual points that you're graphing. You're not connecting the dots with a line, okay? So that's one of the differences here. All right, so next section we're going to do, and this is a real short section, and it is a really, really hard section, so don't worry about this showing up as far as anything really hard on a test. It's just kind of getting your feet wet a little bit, and we will do this on the next video. We'll get started on finding the general term.